tested it, so there we go. What this needs, however, is to have the capacitors changed. So it's basically the Uniden 100 or the Audioline 340, but with the realistic. And I always had the impression that the realistic ones were kind of better set up, or there was something which always worked better with them. I don't know what that was, whether Tandy's had some rather strict control over the manufacturer or what. Just move this camera down a bit, not that much. And it's just my impression. So we're going to whip this open and we're going to change the capacitors that need changing on all Uniden radios. For some reason I need to get a bigger screwdriver on this. These still have the rather bassy audio that on transmit that this Uniden chassis has, and you can soon rectify that by using a speech processor mic. So we don't like to do modifications here because I like the sets to be how they were manufactured, as in when they have their little foibles. I don't want sets to pass through onto other generations to be kind of A1. It's all part of how sets were. You know, like the Fidelity 1000's a bleedover box, and oh, it's got screws in the back. I forgot about that. Date code's 1982 on A2, so it's not from the first batch. And that's why I'm taking both lids off, because we do need to change those 220 microfarad capacitors, and then we'll just go through a tune-up. It should be spot on. I do have one of these new in a box. In fact, I've got all the realistic somewhere new in a box. Perhaps the mice have eaten them. That's interesting. Okay, the capacitors are being done. I won't be doing the capacitors then. Well, this would have been done before 2014 when we started doing these videos. Yeah, so we've got the 220 microfarad there in capacitor 102 position. Just zoom in on that. Let's go in for the fast zoom button. There we go. So we've got 102, that needs to be changed always. And can I see the number on that? 76. That needs to be changed as well. They have been changed, and they're these grey type, and now these are 38 years old. They are playing up. Okay, well, it's not. This is a set that I haven't personally done that to, so perhaps Mark's done that. Okay. So it's more spot on than I thought. That's spoiled our little game. So unfortunately, I don't seem to have got a broken realistic 2001, but I'll go through the tune-up anyway, because I say it must have been done prior to 2014. Now this isn't the original mic, it would be a coffee mic, but this is the correct mic you'd have had as an accessory to buy for the realistic handhelds or as a spare mic. And I particularly like the way these are, because the push to talk bar runs through the switch, the way the screws are, it goes through the switch. And whereas you got a lot of microphones with the plastic mouldings collapsing, it's virtually impossible for that to happen with those mics. And it's also interesting to see the factory original locking DIN, which these have. There's a plastic plug, but it's a locking one. So we put those high quality metal ones on, and some people put those really lousy quality plastic ones on. So that's kind of something in between, with it being a locking one and having that locking mechanism. So we've got the service manual, of course, so we'll power it up and hopefully everything will be hunky-dory. Just plug that into the power supply, switch on, and we're lit up. We used to use channel 37 until there was a foreign taxi firm on the same frequency at certain weather conditions. That's why we're using 31 these days. I'm also interested to see what the sensitivity of this is, because we've been taking these sensitivity readings in recent weeks, and I'll just get up and hopefully we've got the service manual to hand. So luckily I bought the service manual at the time when Tandys were around, and although I was only in my 1981, I was born 62, so I was only 19 and could ill afford £16.99 for each one of these service manuals. Of course, all these years later we're still using them, and it's also enabled me to share them with people, because I've uploaded hundreds of manuals for free use onto Scribe some years ago. So it says it's 3.4 to 4 watts. It's supposed to be 3.7. That's so it's well within the regulations, but 3.4 to 4 is the limit spec. So let's look at sensitivity, and I'll get that notepad and we'll start making a note of the sensitivity from what the manual says before we've even switched on the radio. So realistic TRC2001. I've had some bargains with realistics over the years on eBay, because some people managed to misspell it, but realistic, and it's if you're wanting a realistic something or other, it's well worth doing an eBay search for realistic, like TRC2001 for a tenner and things like that. You think, way. In fact, I think that water damage one we did last week was a tenner. Right, sensitivity for 10 decibel cyanide. They're using 10 decibel cyanide. So, if I can spell manufacturer, it's 0.5 to 1 microvolts for 10 decibel cyanide. So there you go. And current drain, for those people interested with the battery power and all that, is you're looking at 620 milliamps on transmit. Oh no, it's receive. I'm lying. 620 milliwatts on receive with it full pelt. 1.2 amps on transmit. So we'll leave that for later, because that's going to be interesting. Because not that I find the Uniden usually that sensitive in comparison to some of the others, but it doesn't matter. Right, we'll get the multimeter and we'll start by doing the VCO. So I'll get that microphone plugged in. Just like that. And we're going to start with it's on channel 40. Just make sure I'm plugged into the test equipment. I am. And so what we're looking for, because this manual covers both the 2001 which we're doing and the 2000, it's the same chassis more or less. There are differences on the board. Test point 2 I think it is, which is resistor 53. No, test point 1. It goes to just show how many of these I see. So it's resistor 52, which is the test point 1, and that's what we're starting off with. So I'll change glasses. Might be able to see it then. Expect it's in some wax impregnated somewhere or other. It's 55, that's 50. It's going to be somewhere down here. I think it's that one. I'm just going to check with the layout. That's interesting. It says resistor 52. Yeah, 52, that's it. There we go. And it's test point 1. So it's there. That's it. So before we get going then, we'll just see if I'll put the meter kind of there in such a way that we can both see it. I'll just check the power input 13.5 and I'll just check if we're negative earth. No, we're not. So I'll make sure we have a crocodile clip lead onto the chassis. You know, there's 400 different UK legal CBs, over 400. So this is why you just can't remember unless you're doing the same model all day. You know, it's difficult to remember which one. It is for me anyway. So let's see what it says. So we're on channel 40. We go into transmit, and we need to find that there's 3.5 volts on that test point 1. And look at that, there's 3.52. So that's fantastic. That's just what we want. And you know what? My trimming tool's fallen on the floor. I love ceramic floors. They're great at breaking things. So we'd be adjusting L17. And L17 is that lower one. So that's your transmit. VCO transmit 3.5 volts. Now we're going to go to channel 20, it says. And on receive, we're going to be looking for maximum reading on an oscilloscope. So I'll pause the video while I set that test up. So I've just turned the bench light off, so hopefully we can see the oscilloscope. These are just 10 meg oscilloscopes. I can see what we need to see on them. We do have a diagnostic oscilloscope on another bench, but I'm not going to do a bit of video there and a bit of video here. We'll just carry on. So we've got it connected. We've got the red part of the crocodile clip lead to the resistor 6. We've got the black one connected to one of the cans, so we've got the earth. That's what we've got on the screen, and we're going to use the L18, which is a second coil up, just to maximize that voltage. So we can actually drop that voltage, it's going down, and we can go to a point where it starts to compress. So that's going to be our peak just there, and of course it was spot on. So that's covered the VCO. So we'll undo that, put the bench light back on, and that's the oscilloscope we normally show the detector on. So we borrowed it. So change the page. So they have you do the receiver first. We don't work that way. We work with the transmitter first. So once again, they want you to do 15 and 16 for maximum on the oscilloscope, but this time at test point 2. So 15 and 16 and test point 2. So I'll tell you what, we'll do it. We'll fit in with what they say. So we'll go back to that. We'll find test point 2, and test point 2 is resistor 53, and resistor 53 is somewhere up here. I think they mean resistor 33, you know. I think this is yeah. It is. It's 33. It's a lie. The TRC2000, it's resistor 33, so they've made this a typing error. So resistor 53, it becomes resistor 33. So we're going to have to just scrape some of the paint off this. So nobody's ever done this before, but we're just being meticulous for the video. Okay, I'm going to be in low power because this part of the circuit, the high-low power doesn't affect it, so I may as well not get the set hot, which I don't desire to do unnecessarily. So now we've got that. I'll just prove that we are getting a signal. We are, look, that's on. So we'll just maximize these two. The peaks there on that one, and the peaks there on that one. So that's done those. Once again, I'll unplug that and plug it back in so we can do the detector later on. These are all very fine, you know, you're looking at 1mm movement on these screens. So we've done that, 14 and 15, so that's 15 and 16 covered. So we now move on to 14, 13, L12, L10. So I'm now going to go on to high power, and just slightly low on this power supply, aren't we? It was 13.4. Okay, so the radio is currently doing 2.8. There we go. That coil was out. Just goes to show. I'm just going to go on these two stages we've already set up, just to make sure we're about there. Let's go back to that one. So now at 3.5. Three and a good half. I've not got the soldering iron on, and I'm going to need to, because these cores are going to be stuck with the wax. So we can peak that to 4.4. So we'll now just drop that back to 4. Now you can't alter the frequency on radios with the Uniden chassis. Unfortunately, the crystal doesn't have a trimmer, but it's within spec, and I'll show you it's in spec. I just realised I've not been showing you the power meter. There's the power meter, and that's the 5 watts, and there's the 4 watts. And we'll just check low power while we're here. So low power is 0.35. We can adjust that, and to adjust that, it's variable resistor 4. And variable resistor 4 is that one there. I found low power really useful feature, you know, in a convoy with somebody else. You don't have to blow each other's windows out when you're behind each other in your car, and so you can pop it onto low power and everything's hunky-dory. So I do miss that on the later sets, which didn't need to include it as part of the specification. So that's that done. We're just showing you the frequency, and I'll just move the camera across to the frequency counter, which is there. It should be 2779.125. It's 2779.13435. So it's well within, but it isn't adjustable on this chassis. And now these are 38 to 40 years old, and they're still going strong and not off frequency. You know, that they may have saved a few pence, whoops, but it hasn't really caused any problems. I think I've only changed 2 reference oscillator crystals ever. Okay, so we'll go on to deviation. We'll get the little thingy out. Somebody had a question, and I'm just going to widen the shot on this, and then move the camera accordingly. There we are. We're just in. Somebody says about the level control meter on here, and on the signal generator mode. I'll just go into signal generator. What you have to do is to set the signal generator so that it's on that level line there, which it is. So that's your first thing. The second thing is that this meter does is when you're using the deviation and modulation meter, because it's a tunable receiver from 24 megs to 500 megs, you're actually manually tuning it, and I've got to get a peak, which means it's tuned on that meter. So I'm going to key up, and it's currently saying 8. So I've got to get a peak on that meter, and I've done that. Wallow. Well, I thought I had. Wallow. It's not going to play ball. Wallow. Wallow. Have I got a duff mic here? Let's pause the video while I find why I haven't got any deviation. I think we've actually got some dirty contacts in the microphone, and that's quite a rarity. So it's not often I take these mics apart, because it's not often they play up, and you can see how they're strongly constructed. I do hope it's not the leaders. I think the word is knackered. So it's quite a large switch in there, and it goes. You've got the PTT bar, and then it goes through these huge mounting things. It's a really substantial switch. Best I've ever seen, to be honest. About the same size as that Heathkit one I've got from 1964. Wallow. Now that's giving me audio. Because on a CB microphone the audio passes through the switch, in this case it's the red wire. No, it's not. That's transmit. On this one it's the white wire from the mic goes to the white wire in the cable, so it's that one. Wallow. Yep, that's still working, so we'll put it back together. I thought this was going to be one of these 15 minutes videos for transmit and receive all done, because of it being a supposedly working set, but you can still find things to adjust. I mean, after all these years, you saw I was only doing, you know, something like 2.9 watts. So it was last looked at 2014. Wallow. Testing 1, 2. So we've now got deviation. Wallow. And we'll put it back on the oscillator. It is spot on. But I will show you, for showing you's sake, that the deviation is variable resistor 5. And that is down here. If you look at the meter, we've got 2.1. I can make that go up, I can make that go down. So we'll set that back to where it was. I think that control's slightly dirty, so we'll just give that a quick spray of Servicol and work it around. We were talking about budgies, weren't we, saying daft things. I have an elderly lady friend at church, and she's 86. She tells me they had, when she was a child in the 1930s, they had a budgie, Wallow, and the budgie always used to say, when the rent man came every week, "You dirty bugger." He never said that to anybody else, just the rent man. They were most embarrassed over it. So that's gun deviation. We'll just check that the power meter on the radio is saying something like the 4 watts that the radio really is doing. So we're on 4 watts. It's actually a bit high. So what we need to do is adjust variable resistor 3, which is the meter, into the center of the red zone. Done. So that's transmitter back spot on. And in the service manual, it shows you if you're using separate test equipment rather than all in one. And you've got a flow chart for troubleshooting. They're really, really good manuals. And there's the voltage chart for all the components like transistors and that. Somebody once asked me, why am I using the Motorola external cyanide meter when I can see that the test set I use has a built-in cyanide meter? Ever so easy. The cyanide meter in the test set doesn't work. And they're such complicated things that I don't want to take it out of service to fault find it or send it in and spend a fortune. Right, onto the receiver. So we're going to have 2779125 on our signal generator. There we go. I'll put the cyanide meter on and we'll do that detector for a start. Right, I've reset the oscilloscope for how we want it for the detector. I've got the right frequency, 2779125 on the signal generator. we've got 100 microvolts, which is in the UK for a CB radio, S9 position. And there we have, I'll just turn that bench light off so you can see that a little bit better. And what we're going to do is adjust the detector. And it's L19. And L19 is the one down here. See, the logic here is the receiver's IF chip is just there. So now we'll adjust that for maximum. And it was already spot on, so that's fine. So now we'll move the camera onto the cyanide meter. We'll put the bench light back on so we can see what we're doing. And we'll just go through the receiver. So it's 654321. Six, 5, 4, 3, 2, 1. We're going to start with 1. I'll tell you what we'll do first. We'll just look at the sensitivity as the radio is at the moment. And we're going to go for 12 decibel cyanide, so it's not how they've expressed it in the service manual, but it's a bit more standard. So I'll put in the notebook as presented. It is for 12 dB cyanide, .71. Okay, put that to one side, go through the receiver and see whether we can improve on that. So I want about 4 decibels on the meter so we can adjust it. You're always working with the lowest possible signal that you can work with. And we'll go for L1. No improvement. L2. No improvement. L3. No improvement. L4. No improvement. L5. Might be a fraction there. L6. There we go. Just drop the signal a bit more and do L6 again. Okay, so just listening to it, we're at 0.3 of a microvolt there. We can still hear it. About 0.1 of a microvolt. But let's see what it equates to with some real figures. So for 20 decibel cyanide, Okay, so for 20 dB synad, the radio is doing 2.4 microvolts. For 12 dB synad, we're just on this scale, only just. So I'll take another reading off it, because it might not be accurate at the right at the end. We're looking at, so it's 0.6. I'll just go down a scale. It says 0.75. I'm more likely to believe that. And then for 10 decibel synad, it's doing 0.6. So if you remember, the manufacturer said 0.5 to 1 for 10 dB synad. So this is 0.6. So 0.5 is better than 1. The lower you go, the better. So 0.6 is quite above the worst they would expect it to be. So 1's the worst they're expecting, and the very best is 0.5. So 0.6 is a jolly good example. But as radios go, there are more sensitive sets. And this is all my logic. This is why these probably weren't as prone to bleed over, because they were less sensitive. So that's it. Let's look at the S meter. So you don't need that on for that. And the S meter should now be reading S9, because we've got a 100 microvolt signal on it. And it's just on the, it's just that little bit high. It's on the plus of plus 10. So we'll just do the S meter, and the S meter is the preset just there. That's just reined it in that fraction. And that now leaves us to do the squelch. Once again, I'll let you look at the attenuator controls, and then you can, it makes it more meaningful for you. Right, here we go. So we'll switch the signal generator off. It is set for 0.3. So we've got that at 0.3 and that at 0. So switch the signal generator off. Set threshold on the CB for squelch. It's there. Switch the signal generator back on. Nothing. Advance the attenuator, so 1 microvolt, 3 microvolts, so it's come in. So it's, in reality, it's coming in at 2.6 microvolts, and it's leaving us at 2 microvolts. I don't think that's very sensitive. It doesn't impress me anyway. So we'll take the control to the maximum, and I want the squelch to come in at 100 microvolts, in other words S9. So we're at 3, 10, 30, 100. That's where I want it to be. 300. It's coming in too late. So I want more sensitivity than that. So we just need to adjust the squelch, which is the preset here, until that signal comes in. I just wonder if the control's slightly dirty. I'll just put a bit of servicel on it and waggle it around. I'm not getting anything. I'm not getting anything anywhere. That's the most sensitive we can get. That's with it on absolute maximum. So it's still too tight for me. So it's actually, because we're on the 300 range now, that's, I'll tell you when it's coming in. It's coming in at 150 microvolts. So it's like +10 or something like that. So that's the best we can do. So now we'll go back to the other end. I've reset the controls to 0.3 of a microvolt. So we'll turn the squelch down, the signal generator is off, and once again we'll set that to threshold. That's now set to threshold. Switch the signal generator back on. Nothing. Let's see when it comes in now. 1 microvolt. It's coming in easily at 3, so we'll find out exactly where. This is actually better for us. It's coming in at 1.2 microvolts, and it's leaving us at 0.9. That's the best we can set it for. So, bit of a compromise, but that's the best we can do on this chassis. So, there we are. We will put the cover back on this, and then I'll do my usual daft thing and go 1.9 for a Roger. And yesterday we got one, didn't we? Chappie 7 miles away. I nearly fell off my stool. I didn't know what to say to him. Wasn't expecting that. Okay, we're back on in one piece. We've got the aerial on it. That's 19. We're 35 miles from anywhere. And we'll just flick down these channels. It's 7:15 in the evening. One nine a Roger. I keep doing that on channel 20. 1.9 a Roger. No takers. We're back to usual. Anyway, we'll do that later on with Mr. Chippy, and no doubt we will work fine with that. So it's doing a full 4 watts. I've seen more sensitive sets, but it's well within spec, and it's certainly one of the better examples as far as sensitivity goes, according to the service manual. So it's a well used realistic. It's not new out of the box or anything, but there you go. So thank you for watching the realistic TRC2001 made by Uniden in Hong Kong in 1982.